Discuss the applications of exponential functions. But first, what are exponential functions? Exponential functions can be denoted as b raised to x, wherein b should be greater than 0 but not equal to 1, and x could be any real numbers. So we have three main applications of exponential functions in real life. We have the population growth, we have the half-life, and we have the compound interest. And each one of this paper strip has a corresponding problem to each type of application of the exponential function. So what do you want to solve first? Let's have the half-life first. Since you cannot read it, I'm just gonna read it to you out loud. Jessica has been pestering by a colony of black ants. She learned that vinegar could be a way to lessen them. Therefore, after she accumulated 200 ants and kept them in a box, she discovered that every 5 hours, the population was halved. How many ants were left after 8 hours of exposure to vinegar? So this is the half-life. So Jessica is has been pestering by a colony of ants. Therefore, she collected 200 black ants and kept them in a box and applied vinegar. And after that, she discovered that for every 5 hours, the population was actually halved. So how many black ants will remain after 8 hours? So let's see in the solution. Oh, first, let's see the answer. According to this one, it's 66. 66. But how did we reach 66? So let's have the solution. For the half-life here. I'm sorry. So in solving for the half-life, or to verify that the answer is truly 66, we have the exponential model of y is equals to y sub 0 times 1/2 raised to t over t, wherein y sub 0 is the initial value, the starting value, small t would be the given time, and t would be the constant time, if you're getting what I'm saying. So if y sub 0 is equals to 200, small t is equal to 8 hours, and big T is equals to 5 hours, you just have to substitute it in the exponential model. Therefore, the number of black ants that will remain after 8 hours would have to be y is equals to 200 times 1/2 raised to 8 over 5. Simplifying it would have to be y is equals to 200 times 1 over 2 raised to 1.6. There again, y is equals to 200 divided by 2 raised to 1.6. Solving this in a scientific calculator would have to be 65.97, rounding off to 66. Even though the 0.3 actually denotes death, but for me it's just like naghihingalo pa, pwede pa siyang ma-revive. So technically, 66 pa rin yung ants na nandoon sa box na alive. Next type would have to be the compound interest. Since you cannot read it again, I'm just gonna go read it to you out loud. So Mrs. Jacobson deposited an initial amount of 70,000 peso, and she's depositing additional 2,000 peso per month. If the annual compounded interest is 7%, what is her total money after 7 years? So this is another type of exponential function, and according to this, the answer would have to be 382,175.99 centavos. So, want to know why? Here's the solution for the compound interest. In the compound interest, I find it tricky since most of the compound interest examples are no additional deposits, but this has actually an additional deposit. So the exponential model is P, or the principal, times 1 plus R raised to T. However, there is an additional deposit. So the new exponential model would have to be principal plus 24,000 times T times 1 plus R raised to T. So all we have to do, or we have the given. So if P, or the principal, is equals to 70,000 pesos, rate is 7%, and T is equals to 7 years, therefore, her total money would have to be 70,000 plus 24,000 times 7 times 1.07 raised to 7. Therefore, A is equals to 138,000 times 1.07 raised to 7. If we're actually gonna simplify this, it's really gonna be 382,175.99, or the answer. We finally prove it right. Last but not least is the population growth. Here's an example or a real-life application of this. Jemima has a colon cancer. Through the doctor's findings, she knew that her cell is dividing faster than usual. Her cell division rate quadrupled for 10 hours. For every 10 hours. If a normal colon has 7,000 cells, how many cells does Jemima have after 30 hours? So population, actually this one's going to increase, and this is actually a real-life example, a true-to-life example that anyone could really experience. So, want to know how many? Here's the actual solution for that. Last but not least is the population growth. I find it same as the half-life, or the inverse of half-life, since its exponential model is f of x is equals to y sub 0 times 4, since it is said in the problem that the cell division rate quadrupled. Actually, the one in the parentheses changed depending on the rate, or depending on the given example. It could have been only doubled. And then the small t is still the varying time, and then the t is the constant time. So if y sub 0 is equals to 7,000, t is equals to 30 hours, and big T is equals to 10 hours, we could just substitute that value in the exponential model. So y is equals to 7,000 times 4 raised to 30 over 10. Then simplify it, would have to be 7,000 times 4 raised to 3. Y is equals to 7,000 times 64. And then we're going to prove it right that the answer previously is 448,000 cells. So guys, I hope you learned a lot from me today. And let me just get my reflection paper, because I'm gonna share to you what have I learned throughout working on this project, throughout working through this activity, and I hope you learned something from me too. Reflection. Through this activity, I further understood the exponential function, as I already know how to apply it in real life. I learned that there are 3 major examples to show exponential functions. Also, it is very evident in our lives. As you can see, I have given examples that are actually true to life, and everyone can experience it. So you know already where to apply these exponential functions. I finally learned to graph it as well. During the activity, I kind of practiced graphing it and to see the trends of each and every exponential function, to see the graphs of it. And I can say that I really learned from here a lot. I finally understood the lesson, not just merely by Sir discussing it. I mean, I understood what Sir have said, but with this activity, with this discovery approach, I truly discovered what I really need to know. So I hope you really learned from me, and till next time.